Okay, students. Next, we have the atomic structure of hydrogen. Simply the atomic structure. Now, initially, like in 1800s, in the beginning of 1900, when the structure of atom was not known, there were different model proposed by different scientists. Basically, to understand the atomic structure, it took many years for the scientists to understand what is inside the atom. So for that, different scientists proposed their own models. I'm not going into more detail of those models because there are many models, but I will just discuss a few of them which are more important. The first one is J.J. Thomson. J.J. Thomson atomic model. And next model I will discuss here is the Rutherford atomic model, and then I will discuss Bohr atomic model. Bohr's atomic model. So my focus will be on these three models. So first I will discuss, not in brief, but I will summarize the J.J. Thomson atomic model. Now, this model is the beginning of modern physics. Like before the invention or before the discovery of electron, when electron was not discovered, At that time, the concept of atom was there, but it was believed that at that time that atom is an indivisible particle. Like if we have an atom, we cannot divide it into different parts like what we are doing nowadays, because we have atoms. Inside atoms we have nucleus. In nucleus we have protons and neutrons, and outside we have electrons. So we can easily remove electrons from there, or we can easily remove proton from there, or we can easily add an electron to this atom, or easily add a proton to this atom. Now, when electron was not discovered, at that time atom was considered to be an indivisible particle, like atom cannot be divided into subparticles. This was the concept at that time. Now, when this scientist J.J. Thomson, who discovered electron, by using his most famous experiment on cathode rays. Experiment on cathode rays. After that, the belief of this, that atom is indivisible particle, now convert to the concept that atom consists of positive and negative charges particles. Before that, the concept of atom was like a hard sphere, which is indivisible particle. Now, after the discovery of electron by the scientist J.J. Thomson, who did his most famous experiment on cathode rays, after the discovery of electron, the concept now transform these indivisible particles to the atom consists of positive and negative charged particles. Now, how this negative and positive charge, they are arranged inside the atom. Like if we have atoms, inside these atoms we have positive charge and we have negative charge. So how these positive and negative charges, they are arranged inside this atom. So then for the arrangement of for the clarification of the arrangement of these positive and negative charges, different models, like scientists propose different models, and among which the three, like the J.J. Thomson model, the Rutherford model and the Bohr models, they are most important. Okay, so first I will discuss J.J. Thomson model. This is a history behind this model, that why we need this model, and here I will discuss the main feature of this model. What are the main feature of this model? So the main feature of this model is, first one, that atom is a spherical in shape. According to this J.J. Thomson model, it proposed that the atom is spherical in shape. This was the first feature of this model. And then the next feature, the next point of this model is the whole mass of the atom is uniformly distributed. According to this model, the atom is in a spherical in shape, okay, and the mass is uniformly distributed inside this sphere, which is wrong, because we know that more mass is inside the nucleus, while electrons are revolving, which is a less mass as compared to the nucleus, they are revolving around the nucleus. But according to this model, the whole mass of the atom is uniformly distributed inside this spherical shape atom. Now, the third point of this model is the atom has uniform density. The atom has uniform density, which is also wrong, because we know that the most denser part of the atom is nucleus, while outside we have the density, but which is decreasing as we move away from the nucleus. But according to this J.J. Thomson model, the atom has a uniform density. And the fourth point of this model is that there is no empty space. There is no empty space inside the atom. So it means that the whole sphere inside the whole sphere is filled. So there is no empty space inside this atom. So it means that this atom is, if this is the charge, then the charge, it is completely filled by the charge. So there is no empty space. Still we can see empty space here, but according to this model, it is like this. There is no empty space. It is completely filled with positive and negative charges. This is the fourth point of this model. And we know that there are two types of charges now. One is positive charge and the other one is negative charge. So according to this model, the total positive charge or the total positive charges and negative charges negative charges, these charges are uniformly equally distributed. What it means? Suppose we have the atom which is spherical in shape. If we have a positive charge here, then we have a positive negative charge, then we have a positive charge, negative charge, then we have a positive charge. And then again, if there is a negative charge, then there will be a positive charge, negative charge, positive charge, negative charge. So negative charge, positive charge, negative charge, positive charge, negative charge, positive charge. So the charges are uniformly distributed. This is the another conclusion of this model. And the final point of this model is that the electron having negative charge can perform vibratory motion about their mean position. So according to this model, if there is an electron inside this sphere, then it perform vibratory motion. It can move backward, forward, it can move up and down about their equilibrium position. So this was the main feature of J.J. Thomson model. So there were a lot of defects in this model. So to remove those deficiencies, another model was proposed by another scientist, which is called Rutherford model. So here I will explain I will summarize the Rutherford model without discussing the experimental setup. So here we have the Rutherford atomic model. Now, what is the concept behind Rutherford atomic model? Like Rutherford, what he did, he takes some alpha particles, like these are the alpha particles. He accelerated those alpha particles towards a gold foil, which is very thin. Okay, and these alpha particles, after penetrating through this gold foil on the screen, he see a different features. Like these alpha particles, they comes here. Some of the alpha particles they strike straight at this point, and some of the alpha particles they strike like this, like making some angle, some distance from this original path. So it means that these alpha particles, after penetrating, at the time of penetrating through this gold foil, they deflect from their original path. Now this deflection, because we know that alpha particle is a positive charge, so from this deflection we can say that there is a positive charge inside this gold foil. That positive charge repel this alpha particle, so that's why they deflect from their original position. So this was the main experimental setup. I am not going into the detail of this Rutherford experiment of alpha particles, but this is the concept. Now there are the main features of this atomic models are, the first one is that the atom consists of a heavy positively charged region, and he call it nucleus. And this nucleus, which is situated at the center of the atom. This was the first observation of this Rutherford atomic model. Like what he did, he bombarded alpha particle to a gold foil, and we know that the gold foil consists of gold atoms. So it means that if alpha particles, let's say this is the alpha particles, they are coming in this way. So here we have a nucleus, a positive charge region inside this nucleus, inside this atom. So once these alpha particles reach here, then they will be repelled by this positively charged region, so they deflect from their original position, or they deflect from their original path. The original path is this one. So that's why on the screen we can see spark here or here, not in between this region. So it means that there is a heavy positively region inside this atom. Due to this heavily positive charge region, these alpha particles, which are also positive particles, okay, they deflect from their main position. So this is the first point observation which was made by this Rutherford by using this experiment. Now the second one is the electron. Like we know that in an atom we have two kinds of particles now. One is positive charge particle, which is the nucleus, and the other one is electron, which is a negatively charged. So it means that the electrons, according to this model, the electrons are revolving around the nucleus. And the third point of this model is, now if electrons are revolving around the nucleus, let's suppose this is the nucleus and electrons is revolving around this nucleus, okay, then the speed of the electron around the nucleus, let's suppose this is the electron which is revolving around the nucleus in this path. So the speed of this electron around this nucleus is such that a mechanical equilibrium is attained. Like there will be an equilibrium. The electrons are in a state of equilibrium. The equilibriums come from two kind of forces. One is due to electrostatic force of attraction between electron and nucleus. This is the electrostatic force of attraction, and the other one is centrifugal force, like the force which tries to move this electron away from its path. This is called centrifugal forces. So we have these centrifugal forces. So this electron is revolving around this nucleus, so it means that these two forces, they are equal in magnitude but opposite in directions. So we can say that Fc is equal to Fe, or the centrifugal force is equal to the electric force, or the Coulomb force, because we have this electron is a positive charge, nucleus electron is a negative charge, and nucleus is a positive charge. So these two charges attract each other. So there is a force of attraction, or electrostatic force, or Coulomb force. But also we know that when there is a particle which is moving in a circular path, so there is a force on this particle which is toward the center, which is called centripetal force. But there is another force which is away from the center, which is called centrifugal force. Centrifugal force. This is the centripetal force. So it means that there is a force which is opposite to this electric force. So these two forces are equal in magnitude and opposite in direction. That's why this electron is in mechanical equilibrium. So we can say that the centripetal force is V square over R, which is equal to the Coulomb force is K, is the Coulomb constant, and we have charge on nucleus times electron charge divided by r square. This is the Coulomb force. So this is the third main feature of this Rutherford atomic model. Now, apart from the advantages of this Rutherford atomic model, like we now exactly know what is the structure of the atom, how electrons are distributed inside these atoms, how positive charge are distributed inside the atoms. But apart from this importance of this Rutherford model, there are few drawbacks also. So the drawbacks of Rutherford model. So the first drawback of this Rutherford model is according to this model, electrons revolve around the nucleus. Okay, so it means that there are infinite numbers of orbits in which electron can revolve. Or we can say that there may be infinite number of orbits, that is, the electron can rotate in any orbit of any radius, which is impossible in practical life. Okay, this is the first drawback. The first drawback is the concept of infinite number of orbit. The concept of infinite number of orbit is impossible in practical life. This is the first drawback. Now, the second drawback of this model is, according to this model, the electron is continuously accelerating. So it means that if a particle is continuously accelerating and moving in a circular path, so what it means? It means that there is a theory which is called electricity and magnetism. According to this theory, an accelerating charged particle must emit electromagnetic radiation. So the second postulate is, according to this Rutherford model, the electron is continuously accelerated. Okay, so if a particle is continuously accelerated, then this implies that it emits electromagnetic radiation. This is according to the according to theory of electricity and magnetism. But in general, this is not possible, because if an atom cannot radiate or emit radiation when there is no external force acting on this atom, so it means that this concept that the electrons are continuously accelerating around the nucleus is also not possible in practical life. This is another drawback of this model. So I will stop my video here. In the next video I will discuss the Bohr atomic model. Thank you.